Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session.
So the first question we'll be doing is a grade 12 calculus and vectors question. So it's dealing with curve sketching. So once again, if you want your question answered or if you want any help with any math questions, feel free to send us a message. So this question is asking us to sketch the curve y is equal to x and times ln x. So what we should be doing is the first steps should be to figure out what's the domain and range for this. So my domain is going to be when x is greater than 0, because my ln x is always going to be, for x it's going to be greater than 0, and then the domain of ln x is always greater than 0. So the next point, easy points, are the x-intercepts and the y-intercepts. So my x-intercept takes place when y is equal to 0, so I'm going to substitute 0 in and find out what is my x value. Right? So if 0 is equal to x ln x, then I can get ln x is equal to 0 and x is equal to 0. So x is equal to 0 when just x is equal to 0. Ln x is equal to 0 when x is equal to e to the power of 0. In other words, x is equal to 1. So my x-intercepts can be 0 or x is equal to 1. So I have two x-intercepts. The next is the y-intercept. So the y-intercept takes place when x is equal to 0. So I'm going to substitute 0 for my x's. So I have 0 times ln of 0. Right, so that's just going to give me an undefined, because my ln of 0 is never going to give me a proper value. Remember, because we have a vertical asymptote at x is equal to 0 for my ln function. So what I should have is a whole at 0 and 0. So the next step would be to find any critical points. So critical points, just to recap, is I need to find the derivative of my function. So my function is x times ln x. So the derivative is going to be y prime is equal to ln x plus 1 over x times x, which simplifies to just 1. So when I differentiate, I get ln x plus 1. So to find critical points, we should be substituting 0 for my y prime and finding any x values that give me y prime of 0. So I have 0 is equal to ln x plus 1. Then I'm going to isolate for my x. So I have ln x is equal to negative 1. Right? So then I'm going to change from a logarithmic to an exponential form to give me e to the power of negative 1 is going to be x. So then my x is going to approximate to 1 over e, or 0.32. So this is my critical point. Right? So critical points, again, give me a local min-max, or it could be an absolute min-max. I can't say for sure unless I plug it back into my original function and evaluate the endpoints of my range and domain as well. Right? So I found a critical point, so I can see if it's a min-max by using the first derivative. So I can find out when x is greater than 0 and less than 0.32, what's my derivative, and when x is greater than 0.32, what's my derivative. So I can just plug in a value between 0 and 0.32 into my derivative function. So my derivative, again, to recap, was ln x plus 1. Right? So if I plug in a decimal into that, I should get a negative number. So this tells me my rate of change is decreasing. If x is greater than 0.32, if I plug it in, I should get a positive number, which means my rate of change is increasing. So in other words, I have a minimum because I have a negative rate of change, and at 0.32, it changes to a positive rate of change. So this point will be a minimum. So I know there will be a minimum at x is equal to 0.32. Okay. So we're doing a curve sketching question where we're going through and figuring out what are the important features of this graph. So my function, again to recap, is x times ln x. So we found the x-intercepts, we found the y-intercepts, we found the domain, and we're finding the critical point, which was 0.32, and we evaluated the critical point to be a minimum. Right, so if I plug 0.32 back into my original function, my x is equal to 0.32, I can find the exact coordinate. So my fx, I can say f of 0.32 is going to equal to negative 0.37. Right. So my coordinate would be 0.32 and negative 0.37. So this is my minimum point. The next thing I should be focusing on is concavity. So when is my function opening upwards or opening downwards? So concavity means I need to find the second derivative. So just for reference, my first derivative was ln x plus 1. So my second derivative would be 1 over x plus 0 essentially. Right. So when is my function, my second derivative equal to 0? So when 0 is equal to 1 over x, right? And that's never going to be possible because I know my rational function has a vertical asymptote at x is equal to 0. So that tells me that my concavity never changes. So if I plug a value into my second derivative, so if I plug a value, let's say 0.32 into my function, I'm going to get a positive value, which means my function is always going to be concave up. So it's always going to be concave up. So let's combine all the information that we have. So I'm going to draw a rough sketch. So I have a hole at 0 and 0. So I'm going to just keep it like that. And then I have a minimum at 0.32. So I'm going to say that's my minimum most point. So I have x-intercepts at 0 and x is equal to 1. Right? So that means it comes back up here, and then I know concavity means it's opening upwards always, so it's just going to extend upwards. So my function is going to look something like that. So the next question is dealing with grade 11 compound and simple interest. So we're working through question 12. So we're told that Suzanne is using the internet to explore some investment options. She'll be attending university in 2 years. She currently has $2,600 in her bank account that is earning very low interest. She sees 2 low-risk investments on a website, so there's 2 options we need to consider. We're asked to determine the amount of each option and advise Suzanne as to which option would earn more money in 2 years. So let's talk about option 1 and option 2. So let's first deal with option 1. So it's a 2-year term deposit that pays 2.75 simple interest annually. So then I'm going to write my interest equation to be my principal amount times my rate of my interest rate, and t would be my time. So the thing to note here is that my interest rate and time have to be in the same units in terms of time. So my rate has to be increasing annually, and my t has to be in terms of years as well. So my principal amount is 2,600. I start off with my rate is going to be 2.75. So I'm going to say 0.0275, and my term is 2 years, so I'm going to say 2. So I can find my interest by multiplying these together, which gives me 143. Right? So my total amount is going to be my principal plus my interest, which is 2,600 plus 143, which gives me 2,743. So this is how much she will earn after 2 years with option 1. So option B or option 2 would be a 2-year investment paying 2.6% annually with interest compounded semi-annually. So that's important. So what that equation looks like, our equations are going to be different. So for option B, I have my amount is going to be my principal times 1 plus my rate over time. And then I have something over here. So my n is going to be how many terms is it going to go through. So A is going to be principal. So my principal is 2600. 1 plus my rate is still, was it 2.6%? So I'm going to write that as a decimal, 0.026. Divided by how many years is it going to take? It's going to take 2 years. But it's compounded semi-annually. That means my rate should have an exponent of 4 because how many terms is it? It's 2 years. If it's semi-annually, I'm multiplying this by 2 to tell me that each one of the years has two compounding periods, right? So my total compounding periods would be 4. So this is what the equation is going to look like. So I can evaluate this to be 2700, 37.85 as my total amount. Right, so when we compare the two options, option A makes 2743, option B makes 2737. So we're trying to find out what's better, so the better one has to be option A. So we're going to say option A will make the most money, so we're going to say option A is better than option B. So we're going to move on to the next question. So it's a grade 9 math question dealing with equation of lines. So we're asked, one point on the line is -1, -1, another point on the line is 9 and k. If the slope of the line is 1/2, determine the value of k. So we're given the slope, so we know the equation for the slope as well. It's y2 minus y1 over x2 minus x1. Right? If we're given 2 points, so we're given -1, -1, and 9 and k, we can use these 2 points to sub them in to find this unknown value k, because we have slope, we have all the variables except for one of the y values. So if I substitute this in, I end up with 1/2 is equal to, I'll say this is 0.1, this is 0.2. Right? So my y is going to be k minus -1, and then it's going to be 9 minus -1 as well. So then I can evaluate what k is by isolating for k. So I have 1/2 is equal to k plus 1 over 9 plus 1 is 10. So in this stage I can multiply both sides by 10 to give me 10/2, which simplifies to 5, and then k plus 1 on the right side, and then if I get k by itself I get 5 minus 1. In other words, k is going to be 4. We have an elementary math question. So this is talking about finding the volume. So volume, we need to use the equation which was base times height times length. Length times width times height. Base is length times width. Right. So my length I'll say is 8 centimeters. My width I'll say is 7 centimeters, and my height is 3 centimeters. So when I multiply them together, I should get 168 centimeter cubed because I have 3 centimeters. So my volume ends up being 168. We'll move on to the next question. So this is dealing with grade 10 factoring. So we're given, find all the values of b so that x squared plus bx plus 10 can be factored over the integers. Right? So I'm going to rewrite this, x squared plus bx plus 10 can be factored over the integers. So what we have to do is evaluate how we factor. So factoring is usually we evaluate the c, that means the constant, and see what are the factors for that constant, which add up to my b value. So my b is essentially the sum of factors for 10. So 10, I can have factors such as 1 and 10, 2 and 5, and I could also have -2, -5, and -1, -10. All these will multiply to give me 10, and all these I can add them up to give me my b value. So my b could be 1 plus 10, which is 11, or it could be b could be 2 plus 5 to be 7. It could also be negative 2 plus negative 5 to give me negative 7, or it could be negative 11 if I add negative 1 and negative 10. So the four values b would be 7, 11, negative 7, negative 11. Okay, so we'll move on to the next question. So this is grade 10 trig. So they're given an isosceles triangle that has two sides of 9.6 and two 53 degrees base angles. What's the perimeter? So let me redraw this. So isosceles meaning two sides are the same length, so 9.6 centimeters and 9.6 centimeters. And so both these angles are 53 degrees. Right. So what I could do is I need to find this side, so I'll label this side as x. So I can use sine law or cosine law because I can find out what this angle is, right? So this angle is going to be 180 minus 53 minus 53. So that ends up being 74. So if this angle, I'm going to redraw this to be 74. Degrees, then I can use sine law by using a pair of angles and a pair of sides. So I can say sine 74 over x is equal to sine 53 over 9.6. So then I can isolate for my x value to be sine 74 over 53 times 9.6. Right. If I evaluate that, plug that into my calculator, I should get 11.6 centimeters. Then they're asking for the perimeter, so I'm just going to add up the two equal sides, 9.6 plus 9.6, plus my new side that I found to be 11.6. So this all adds up to 30.75 centimeters. So it's a grade 12 advanced functions trig application question. So we're told a 150 centimeter tall person stands on the bank of a narrow river and observes a flagpole on the opposite bank. The angle of elevation to the top of the flagpole we're given is 0.25. So the angles are given in radians in this case, right? And the angle of depression to the bottom of the flagpole is 0.09. Determine the flagpole's height in meters to the two decimal places. So we have to draw a basic diagram just to get an understanding of what we are dealing with. So we have a person that's 150 centimeters tall, and it stands on the bank of a narrow river. So let's say this is the bank, and there's a flagpole on the other end. Right. So that means the angle of elevation to the top of the flagpole would be from where the person's looking at. So that angle of elevation would be according to the horizontal, which would be 0.25. And the angle of depression to the bottom of this flagpole would be 0.09. And we need to find this angle, this side length, which is my height. Right. So what we can do is break this up into two small triangles. So we have the depression, which is 0.09, and we know the height for the depression is going to be 150 centimeters. So we can use that to find the distance across the two banks. Right. So this is my right angle. So I can say tan of 0.09 is going to be 150 over my adjacent, which is d. So my distance is going to be 150 over tan of 0.09. So my distance ends up being 1662.2 centimeters. So what we found was the distance between the person and the flagpole so far. Right? Why is that useful? Because we can use that for the second triangle, which deals with elevation. Now we have the distance. and we can find the rest of the height minus 150, and we know the angle of elevation to be 0.25. Right? I can account for the 150 later on, so I can find what height is by plugging in my tan equation again. So tan 0.25 is equal to height over my distance. I now know my distance, so my height is going to be tan 0.25 times 1662.2. This evaluates to give me 424.4 centimeters. Okay, so that's not my final answer, because what I've found is the height from the person's viewpoint to the very top, so I need to account for that person's height as well. So my total height, h, is going to be 424.4 plus 150, which is 574.4 centimeters. So we'll do this question. So it's asking, it's a grade 12 advanced functions. It's dealing with trig functions and properties of transformations of trig functions. So it's asking me to tell them the area, the amplitude, period, phase shift, and vertical shift. Right. So the trig function usually takes the form of fx is equal to a. We have sine or cos of dx minus h. We can use k, d, and then plus c. So let's go ahead and see what each of these does. So a is going to be a vertical compression or vertical stretch. So in other words, it's going to change the amplitude. K is going to reduce the period, so it's going to be a horizontal stretch or horizontal compression. So K will determine what the period is going to be. D will be a phase shift, so if it's either going left or right. And C will tell you what the axis of symmetry is. Okay. So we're given an equation, fx is equal to negative 1.5 sine 2x plus 30 minus 1. What we should do is get this equation in terms of the proper form. So what we're going to do is just factor out a 2 inside the bracket. So we have 2 and then x plus 15. Now it's going to mirror what we had initially, so we can describe the amplitude, the period, the phase shift, and vertical shift very accurately. Right. So what we have is an amplitude given by just the a value, which is just 1.5, right? But the negative is important because that's telling me my function has been translated across the x-axis. So it's been mirrored across the x-axis, right? And then when we're talking about the period, we're going to account for the period by the k value, which in this case is 2. So I can find the period by doing 360 over k. So in other words, it's going to be 360 over 2, which gives me 180 degrees as my period. And my phase shift is plus 15. So it's just going to be the negative of that. So it's going to be minus 15. And my axis of symmetry is going to be my c value, which is negative 1. So it's going to have an axis of symmetry of y is equal to negative 1. So this is a grade 10 math question. It's talking about the equation of lines. So they're telling us to determine 2 more ordered pairs that lie on each line. So for 5, let's start with 5a. The rise is 3, the run is 4, and 2, negative 5 is on the line. That means I can find the slope, because we're always trying to get, we can relate the slope to a different point, right? So what we could do is write the equation in slope-intercept form. So y equals mx plus b. Right? Because when we find the equation in the slope-intercept form, what we could do is figure out infinite number of points based if we plug in a random x, for example. So what I mean by that is, let's go ahead and find the slope first. So my slope is going to be rise over run, so it's going to be 3 over 4. Right? So my equation has a slope of 3 over 4x plus b. I don't know what the b is, but I can find it out by substituting the 2 and -5. So I'm going to say -5 is equal to 3 over 4 times 2 plus b. So this simplifies to 3 over 2. I can do -5 minus 3 over 2 is equal to b, which gives me -10 minus 3 over 2 is equal to b. So my b would end up being -13 over 2. Right. So my equation is going to be 3 over 4x minus 13 over 2. Why is that important? Because I now have an equation that's going to model that particular case. So it has a rise of 3, run of 4, and has that point. So this equation is accurate to that system. So what I can do is plug in a different point to find out what another y value is. So for example, if I plug in 4, so 3 over 4 times 4 minus 13 over 2. So this ends up being y is equal to 3 minus 13 over 2, which ends up being 6 minus 13 over 2. So my y would be -7 over 2. Right? So I found a different coordinate just because I plugged in a different x. So my x would be 4, my coordinate would be -7 over 2. So that's another ordered pair, or in other words, a different point on that graph. So they're asking me to find 2 more ordered pairs. So what I'm going to do is plug in a different x again. So my equation is still 3 over 4x minus 13 over 2. So now I can pick another one to be, let's say, it's going to be 8. So minus 3 over 2 ends up being 2. So 3 times 2 is 6, minus 13 over 2. And then we have 12 minus 13 over 2, which simplifies to -1 over 2. So we have my x value initially was 8. So in my coordinate, my x is going to be 8. My y is going to be -1 over 2. So we found 2 values, 2 coordinates. So we have 8 and -1 over 2. And then we have 4 and -7 over 2. So when they say ordered pairs, we're just finding the coordinates. And we can find the coordinates by finding an equation in terms of slope-intercept form, which is what we did initially. And then we can plug in some values of x to find the values of y that correspond to them. That about does it for me today. So just a quick update. Our next live will be on Wednesday. So if you want any questions done, please feel free to send them in beforehand. So thank you again for tuning in. Hope this has been helpful. This is T from Ask Zylor signing out, and hope you have a great night.